My name is Dilip. I am working as a senior principal at Enterprise DB, and I am presenting this talk today with Rushabh Lathia. He is also senior principal in Enterprise DB. We have been working in PostgreSQL code base since almost 15 to 20 years, and today we want to share our experience, or we want to discuss about some of the challenging customer issues which we have faced during our work in PostgreSQL or working with Enterprise DB. We also want to share that how we what those issues are, how we can detect them, what are the strategies to resolve or at least or prevent them, or and we are going to talk about certain examples of some issues and best strategy. So here is the agenda of our talk. So first we will discuss about what we call critical PostgreSQL issues. What are the key challenges in detecting those issues or debugging those issues, and why immediate actions are very necessary in those cases. Then we will take you through some of the examples. Because of time constraint, we cannot talk on all the issues, but there are 4 issues we identified and in different categories, and we are going to talk through those. We will see how you can detect them and how to prevent them. And finally, we will talk about the best practices in PostgreSQL which we can follow, so that in some cases we can prevent those issues, or we can do it early detection at least, so that issue does not become so critical or not become a cascading failure where you get into a database shutdown or service disruption. Okay, so as we all know that severe database issues, whether it is in PostgreSQL or any database, it cause major performance issues. In some cases, it cause data integrity issues in case of like index corruption or so, and it ultimately, if you not tackle on time, it can cause a system availability issue as well. As I told that if we delay the resolution or identification of issues, it can go into a downtime, a financial losses, and also customer dissatisfaction. And these issues can escalate very quickly into cascading failure because of one issue. If it is not resolved, it can become and cause another sort of issues. For example, if it is a corruption kind of issues, it can go into your backups, your replicas, and then it's become very hard to get rid of those. What are the key challenges while dealing with those issues? So when we talk about our normal development environment, when we are just having a PostgreSQL instance and we are debugging some issue, it's very easy, right? You can shut down your database whenever you want. You can attach to GDB. You can debug and identify what is the cause of the issues. But when we are identifying into a real world example use cases in the customer environment, there are a lot of interdependencies. There is not only the one component which is PostgreSQL, but there are various different software is running, application code is there which is not completely understandable by PostgreSQL engineer. There are also OS and hardware involved, and other replication, external replication software, and like a lot of interdependencies is make it very critical to identify those issues. That is what the point is. And we have to prioritize resolving them to maintain the service availability. So basically, one important aspect is that you cannot afford to lose the service, right? You need to keep the service going while you are identifying the issue. So we cannot shut down and identify or restart a database and try to solve the issues, right? We need to keep the service availability in most of the cases wherever it is possible, while we need to debug the issues also. That make it even harder. And it also required a coordination across different team, like DBA team for identifying what queries to run to diagnose the problem better, a DevOps team, and also the application developers who have written the application running on the database in order to resolve the issue faster. Okay, so why immediate actions are very necessary in these cases? So one of the main reason is to prevent a minor issue from turning into a major system failure. One of the example I would like to share is uh, suppose due to some of the index corruption in the system, your table get a duplicate key. So if we are not monitoring a system or we are not identifying it early, that duplicate key can turn into a lot of duplicate tuples or into the same table, and then the same thing can go to your replication as well as into the backup, and there is no way that you can really get rid of that unless you drop the table if it is a single table. But in case of it cascaded it to multiple tables, a foreign table, then it's become really hard to resolve that issue. But if you identify it immediately that there is something gone wrong, you can reindex your indexes and you can prevent that issue early. And protect early identification will protect the data integrity and ensure the business continuity. Same thing what I discussed in previous example, right? Your integrity is not failed because of anything, and it should not become a cascading. And also it reduces the operational risk, and of course it improves the customer trust when we are able to detect the issue early, and when we are able to prevent those issues early. I'll hand over to Rushabh to talk about how we handle this thing in Enterprise DB.
Okay. First of all, hi everyone, and I just want to add, like, this talk is basically we plan to kind of discuss not only the issue which are on slides, but be it interactive. If you guys have any question in between, we are happy to answer, and if it's taking longer, then we can also discuss after the talk. Okay. So yeah, EDB is into the Postgres from a very long time. I guess the first release from the EDB side was 8.3 version of Postgres, and since then, now today we are at Postgres 17. So yeah, it's a long journey, and I and Dilip been with the EDB more than 10 years, and we are going to share what we learned with our experience while handling the Postgres critical issues. Okay, so Postgres EDB has a certified Postgres experts which can respond any type of issues, which basically reduce the risk and also protect the revenue and the reputation across the globe. There is a support who is always available on a virtual assistance. So if any customer has any sort of issue, support just goes on a virtual call with them and try to identify the issue and solve the problem as soon as possible. EDB brings the Postgres internal expertise as well as operational expertise. What it means is, like, for any sort of issues, there can be a two sort of problem. One might require you to handle the operational expertise. What it means, like, sometime customer says, like, I have written these backup scripts, but it's not working, or it's not working as expected by them. So in that case, or I want to do the point in time recovery, can you help us? In such scenario, the operational expertise will be real helpful. And apart from that, EDB has a Postgres internal expertise, by which it means, like, we have a Postgres core developer in a group who can always discuss the issue with the customer and try to provide the fix or resolve the issue as soon as possible. Many a time we have seen, like, there are customers where their system is down. We identified the issue, we provided the patch, but it's really hard to get this into the Postgres because of the release cycle point of view. So EDB comes in between there and provide the hot fix to the customer so that their system doesn't stop and it continues to run and continues to run their business. Yeah, as I said, it offers the proactive support, including the fundamental source code assistance, as well as they will also get the unlimited access to the customer portal. So EDB has their own customer portal, which has a lot of knowledge base, and history about the previous issues. As I said, like EDB is into business from 8.3 version, so have seen lot of issue around the Postgres and many a type of the issues. So anyone who is kind of subscribed to EDB can also get access to their portal. Okay. So in this talk, as Dilip told, like we can't cover all the issues, but we try to identify the things which kind of a common issue across the PostgreSQL. We are going to discuss these four things: how sub-transaction cache overflow happens in a Postgres, how you can prevent it, and how you can come out of that problem. Then there is a database corruption. The third case is quite common, and I guess everyone might have seen or in their Postgres experience. That's auto vacuum failing and causing a transaction wraparound risk. And the fourth one is streaming replication lag. So we will be discussing all these four cases. And again, I want to just say that feel free to ask the question. If you we'll also provide the slide deck if anyone wants. So maybe I have seen that people are taking the pictures, so it's fine if you don't take. So yeah, I'll hand over to Dilip. He will discuss the sub-transaction cache overflow, and later on I'll jump in for the database corruption.
Yeah, so while identifying a number of issues, we were just thinking that what issues can make more sense to discuss. So one of the issue what we selected is sub-transaction cache overflow. One of the reason of this is I being biased is because I am author of fixing this problem in PG17, so I always talk about this issue. But another thing is that this issue is not as common as other issues we are talking about in Postgres, and many people might not be aware also. But once this issue hit, it completely disrupt your operation, and if it is not timely identified, it can hit your system availability. So I think I would, and I have bad habit of going sometime deep into technical, but here I don't want to, so I'll try to stop as much as possible. So problem is that when you have a top transaction, and under that you can create a sub transaction. You can create a sub transaction by save point in PostgreSQL, or you can have exception blocks which internally create a sub transaction so that you can roll back on the exceptions. If that crosses a certain limit, so per backend have a limit of holding a 64 sub transactions, and that is, we assume in PostgreSQL it was assumed from long back that is good enough for any operations to not cross the 64 sub transaction within a transaction, and even if you need to, you can break those transactions into a multiple transaction. But we come across the cases specifically from a customer that it was not always true, and sometimes they need 300 or 900 sub transaction within the same transaction to maintain their performance. So yeah, it was done to maintain the performance, but hit so hard that whole system stopped functioning. So that is the impact of this issue. So what happens is, if you cross the limit of that 64 sub transaction, we don't maintain into that cache of per backend. Instead, it goes into a shared cache, and that shared cache is called a SLRU. The name is very simple, least recently used cache, and this is backed by a disk. It means if even that cache is overflow, it goes into the disk. And performance of course degrade because of two things. One thing is that I told from local backend memory it goes into a shared memory, so there the locking will be required. So lock contention is one problem. Plus if number of sub transaction to parent mapping, if you want to look up, is crossing that SLRU cache also, then it goes into the IOs and it become real problematic. So it increase query latency, and sometime this first time I see in one of the customer cases where the new connection was not able to happen. So nobody will believe that when the connection is not able to happen to database, it is somewhere related to SLRU. Then somehow I was lucky that
yep. Is the sub transaction cache make our disk fragmented? Is sub transaction cache?
The sub transaction cache into backend, you are saying?
I am saying that is cause making that our disk fragmented.
This SLRU cache can be fragmented, but sub-transaction per backend cache is the 64 sub-transaction, or per transaction you can hold a 64 sub-transaction, that's not a fragmented. Okay, so I'll go into that connection failure again. So the case was hit when I was looking into one of the case where connection was not able to happen to the database, and nobody would have imagined, even I wouldn't even imagine it is somewhere related to SLRU. We were lucky to somehow attach the GDB and see the cache, see the backtrace and identify that for connection also we need to access the system catalog for authentication and all these things, and that time it was going into a SLRU cache. So the bad part of SLRU cache is if any of the transaction have crossed that limit, all the system connection, whoever is working on a visibility or snapshot, will need to check their visibility using the SLRU. They need to access this SLRU cache and the disk, and that was the major problem here, and that was allowing that connection was completely blocking in the system. So I think the extreme case is the connection failure, but yeah, in normal cases when you are the system is not very heavily loaded and you don't have a lot of long running transactions, then also you will start experiencing a slow performance and timeouts. Any question in this? Yes.
So it means that the customer has created 64 save points within the transaction.
Yes.
That really like why would is that a good practice, or like is that something?
Right. So as I told that it was my belief, or I think most of the PostgreSQL developers believe that 64 is enough. That is what the limit was set, right? So I will not go into the specific customer case, but somehow they convinced me and a lot of other developers that that was a necessity to have more than 64 sub-transaction into their system.
Is there any use case, particular use case to have that many transactions?
Okay, so I will not go into that particular.
I think one thing is like it's not only save point, it also the exception block. When you create the exception block, that also creates a sub-transaction. And let's say if there is a one procedure and you're calling that in a loop and it having a sub-transaction, it having an exception block, right? That also can hit there.
Okay, so when we'll go into the cases, we'll go into right cases and wrong cases, and they will discuss that.
So when will the sub-transactions, I mean, how do you classify transactions versus
So in PostgreSQL, when you create a begin or start transaction, that is main transaction. When you say save point and save point, save point, save point, those are the sub-transaction. So that is the external sub-transaction which is defined by user. But internally, when you create a procedure, if you declare an exception block for rollbacking purpose. So in PostgreSQL, if you don't want to roll back whole top level transaction, but only a part, that is what your intention with the exception block. So that time it will create internal sub-transaction. Yes. Right. Okay, so as I told very beginning of my talk that early detection of these issues are very important, and I think when I talk about that particular case where the net connection was failing, it would have been very much possible if they would have observed the wait events. Okay, so Rushabh will talk about these things in the best practices, but yeah, you need to observe a regular wait events, and if you would have observed very early, you might have started seeing a subtrans SLRU subtrans buffer. It will show a contention on a lock, that this lock somebody is waiting. And in PostgreSQL, if you ever see this wait event, other wait event, it might be accepted in certain cases. Some lock contention is possible in some particular peak load, but this wait event will only come if you are exploiting or if you are crossing that 64 limit of the cache. Otherwise, that wait event you will never see it. So that is what second point is. If you see that wait event, it means you are crossing the 64 per backend cache of the sub-transaction. And then you will see a high contention on SLRU related lock as well as a lot of IOs. Cause of the issues. So one part is that if you are accessing a lot of transaction information because of some long running transaction, your snapshot range is very wide, it means you need to access the SLRU, but the transaction information is not fitting into that SLRU cache. So you need a buffer eviction that will turn this issue into a bigger failure. But even though if you don't looking for very wide range of sub transaction, but still you are looking for narrow range which can fit into the cache, you need to write that information also and read also, so that contention will also be there frequently on that SLRU. Okay, so what are the mitigation plan, or in fact prevention plan? So you need to review your application, as I think someone recently asked that what was the use case for that. So I have seen in most of the cases except this one case, there was really not use cases, but it was a miss or unawareness from the application developer, where they have written a nested sub loop sub procedure, and with the exception block which is crossing the depth level more than 64. So it will cross that limit, and as soon as you cross that limit, it will start getting a wait event, and then you will go that slowness of the performance. So we need to identify first. The first thing is not to fix anything or try to go to the version where it is fixed, but first thing is whether it is intentional or by mistake. And if it is intentional, is it really necessary for application, or you can just come under a 64? Suppose you are using 80 sub transaction. Why it is so necessary to use 80 transaction? Why you cannot come under the 64? You can break down the transaction into a multiple transaction, and can you deal with that? So that is the suggest those pointer first, and if we think that application can be modified, then we better modify that application. In this particular case, application was, they could not modify the application, and the use case required that many sub transaction to handle the business case of the performance. So in this particular case, it was really hard, that because they identified the issue, it was related to SLRU. We thought we can attempt to fix this in PostgreSQL. Before we attempted in PostgreSQL, it was there a long history in PostgreSQL. People tried for last at least a decade for solving that problem, but it was not fixed, and a lot of blogs were around that how to avoid that, how to avoid the sub transactions. Many blogs were around that, but once the problem become in-house and it's like very personal, then you go beyond, you go extreme to solve such problem.
There is a reason why 64 was the limit. So suppose the use cases is demanding more than that, what is the repercussion to the limit that has been set by the system developers?
I think still a lot of Postgres developer or core members, they still believe that application should not use more than that number, and if you try to exceed that number, having a bigger cache which is held by the snapshot, it will impact the snapshot, and eventually it will also have a performance impact if you cross the boundary of 64. So we did not fix in that area, we fixed somewhere else. Yeah. So we provide a custom build to customer in this particular case, just to see that our fix is really helping them or to solve their problem, and it solved that problems, and we were very confident that we can at least go to the extreme where we can again propose a new strategy in PostgreSQL. What was the problem, whatever suggested in past, we try to overcome that and come up with completely different idea. So we come up with the idea which is not related to the 64 sub transaction cache, but the SLRU cache. So design is still same, that if you cross the 64 limit, it will go into the SLRU, but we added first thing a GUC to so that you can configure the SLRU cache, bigger or smaller. If you are looking wide range of transaction, you can avoid a frequent buffer replacement by increasing the size. And second thing is, we also optimized a lock contention on that cache, that if you have multiple people are looking into that cache, they are not contained. Instead of, we divide a cache into a partially associative cache, so that a contention is not at a single point, but there is multiple small caches are there to avoid that contention. And after that, I think, So such issue is there, and if you think, you also think, which I don't suggest, that if you still think that you cannot go under the 64 limit, then PG17 could be helpful for you. Okay, I'll hand over to Rushabh for discussing the corruption issue.
Yeah, here it is. Subtransaction SLRU.
Lock, wait type is lock.
Okay, you might think like why there is a need of 64 transaction or something like that, subtransaction. But if you talk with the Oracle developer, this is quite common practice for them to use such way. So like it was not that surprising after understanding the customer case, like okay, yeah, there can be a requirement and we need to kind of work for this particular case. Okay, so next case is corruption, database corruption. I know it's seems pretty interesting, but yeah, what is corruption? So database corruption occur when the data stored in a database become inconsistent, unreadable, or lost due to some various factors. What it tells is like, as when someone use the database, their expectation is okay, I'm inserting this data into the database, and then when I want to select that particular data, I want exactly the same data, right? That's a basic requirement. And sometimes you don't get it, and that's lead to the corruption. I mean, that says that your database is corrupted. What are the common causes for the database corruption? We have seen that there can be a hardware failure, that means corruption in a disk or some bad memory, or sometime power failure when some transaction is going on, those sort of issues. There can be a software bug. I mean, no software is bug free, right? So there can be an issue in a PostgreSQL. There can be an issue in extensions which you are using with the PostgreSQL. There can be a OS or kernel file system issues there. There can be admin errors. What it tells is like incorrect system reboot or unsafe file modification, especially into the Postgres data folder. That obviously leads to the corruption. And we have seen such case like a customer are using probably kill -9 things or not a safe shutdown to the PostgreSQL, and those are the practices that will lead you to the database corruption. There can be a user error, like customer has a backup and sometime and they don't have a backup test facility there, and they just restore the faulty backups to the production. While upgrading a database or while upgrading the OS, they might do something which can lead to the database corruption. I know corruption is rare, but it's really serious, and prevention and quick diagnosis is really important in these cases. Okay, how someone can detect the corruption, how or when someone know that my database is corrupted, right? There can be a case where your database is running perfectly fine unless you kind of hit that particular block or try to read that particular relation, and then you realize, oh, it's corrupted, right? So it's better to kind of keep a watch and try to understand like what are the symptoms of corruption. There are unexpected errors in a Postgres logs, like okay, could not read block X from the relation Y. There can be a invalid page header in the block, or there can be error like cache lookup failed. Those are the signs of corruption, and you should not ignore such errors into the Postgres logs, even though your application is working perfectly fine, right? It's really important to kind of diagnose these, try to understand these errors and see early diagnosis is really better in case of corruption. You might see inconsistent query results, as we discussed, and in some cases PostgreSQL startup fails. There can be some random server crashes. So yeah, many unexpected kind of results when your database is corrupted. Now how you can detect the corruption? You, as I said, like check PostgreSQL logs, look for the IO errors or the corrupted page messages into the logs regularly. You don't assume that okay, my system is fine, so I should not look at the logs. This actually kind of practice is applicable for all kind of cases. We have seen that customer doesn't bother about the logs, and sometime if they face the issue, that time that particular try to see the logs. But there might be a history about that corruption or any case where you need to kind of look at the logs from very beginning. So it's really important to kind of keep a watch on the logs. You can use the PG cat check to kind of identify the PG catalog corruption. So PG cat check is a module which basically look for the corruption in PostgreSQL catalogs. So any operation you do on a PostgreSQL, their entry goes into the Postgres catalog tables, and sometime if your catalog table is corrupted, you will get various errors. So this module is something which will basically, it won't fix your issue, but it will detect the issue and will let you know that okay, this particular entry in this your catalog is looks fishy. You can run PG dump or PG verify checksum. If those are running fine, that means your database is fine, and this can be kind of, it fails if your database is corrupted. There is also extension AM check, basically checks for the index and table integrity. So if you have any problem with or issue in the table corruption or the index corruption, this module might be helpful. You can also look at tools like PG vol dump. Basically, it dumps your vol files, and you can look for the missing sequence or the broken records or the usual transaction behavior in the output of vol dump. The output of vol dump might be not really easy to read, but yeah, once you understand the format and everything, that can be also helpful. Any questions so far?
Does AmCheck checks the integrity of all the types of indexes?
I think so, right?
Yeah.
Yeah. Yeah.
Like how do you use PG vault dump?
It's a tool.
Or how is it? It's a tool.
Okay.
In the context of database corruption,
Mm-hmm.
how do you use, in what scenarios?
There should be a regular practice. I won't suggest that PG vol dump should be a regular practice, but yeah, when you have corrupted something or you find out, you can look at the PG vol dump to see.
So in some cases your vol dump will start failing also, that if you are not able to identify particular blocks or something, you identify which exactly vol file is corrupted. So suppose if you are seeing an incident where something is getting corrupted into standby itself, standby node you are setting some corrupted data, you can scan the vol at primary itself, that whether your vol itself got corruption or somewhere standby disk is causing that corruption. So those sort of cases you can add.
You had question? It is possible, online. Yes, but for that you need to have a checksum enabled to your database. I think I can't give you the exactly percentage, but yeah, if you ask me honestly, yeah, we have seen that many a time the issue is with the OS or the bad memory is something we have observed. If you don't find this sort of kind of issue, and it's really hard to tell the exactly percentage. Yeah.
In my experience, I think I've seen the more cases with respect to hardware and OS related issues or buggy kernel issues. Like sometimes we are asking file size, they give a smaller file size. One of the, I think Reddit bug was there with an amount of file size what OS is giving us is smaller than what it's supposed to be. So in that Postgres assume that okay, this is the file size and we can start writing into the next block itself, and we write it and we corrupt the data, right? So it is a mix of decision of software plus OS as well. So
how did you fix this kind of issues in general relating to OS?
Yeah, so when the OS related issue and corruption is there, we identify what sort of corruption is there. Suppose your corruption is there, it get into a index somewhere that you cannot able to, if you try to search a row with the where clause, you are doing an index scan, if you are not finding that row, then we try to look into a table by switching off the index scan. If you are able to find the row in table, you are lucky. that at least row is there, only index is not able to find it, and index is corrupted, you can reindex the index. On the other hand, if it is not there in the table, or the foreign key and primary key mismatch happen because of certain bit flip, and because of that we could not identify the row and we just inserted into the primary without inserting into the foreign table. So in that case, if you identify if it is a very few incident or only one place or so, then you can manually fix those things. But if you start to find it random places by when you start to scan the tables, if you identify any such incident, generally I do either scan all the tables, or we can take a logical dump also of the whole database to identify that, because PG dump identifies such issues very quickly. It can find the broken blocks, or if it's not able to scan. So you need to take this action.
So second question, so what kind of configuration problem on the operating system side causes this problem?
I'm not really an operating system expert, so I'm
Yeah.
not sure that what sort of configuration of OS causes this problem. But I have seen certain sort of like ZFS file system. I have seen such corruption problem and.
Or the OS upgrade, like most of the time customer do the upgrades, OS upgrade, and they think, okay, my database is fine, I don't need to test it, and they continue running their database, right? It's very important when you do any software upgrade to check the consistency of your database, health of your database.
Okay, so you suggest basically using PG verify checksum after doing
I'm-
this upgrade.
I'm not suggesting any particular one thing because everything is for the different sort of problem, but in general, PG dump is something which can be used because it scans through whole your database, and if there is any corruption, it will give you the promptly hint.
Thank you.
I think PGDump is the best one and the easiest way.
Right,
Yeah.
right.
Point you to the exact table or
Right, at least you identify the corruption. It's good to use PG dump
Yep.
to ensure it is not there anymore.
Yeah, but if you have checksum enabled database, it's PG verify checksum is something which you can do regularly job to check the health of your database.
Is there any performance overhead like checksum?
Yes.
There are, but it's not that huge performance.
Basically, you have to compute the checksum while flushing the disk into the
Right.
block and while fetching. So that overhead is there, but that comes with the benefit of not getting corruption into your system.
To avoid the corruption is what you're saying.
Whenever
Detect-
corruption, I do detect the corruption early.
Yeah, it detects the corruption early.
Is it okay to keep the data checksum GUC as on forever?
Yeah, it's pretty okay. Yes.
Yeah, many databases run with data checksum unable where they cannot afford the corruption or these sort of problem.
Yes. And also PG cat check, it's a good module, and it basically check the corruption into the Postgres catalogs. And so if you have kind of a regular job, you can try using those modules in your job to verify the database health.
So PG will be able to detect whether we have deleted the catalog files or not.
Not catalog files, catalog entries, or some due to some corruption, some catalog entries mash up. Like, okay, you created the table, but their column entries are not present into the catalog, so it will complain about that.
I think even daily vacuum job can be used, right?
Vacuum is separate problem. I think that's we'll discuss during the another case. Yeah, these are some of the things which you can try out to kind of recover from your database corruption. First and important, identify the cause, and it's in this case it's really hard to kind of identify the cause. I would say first thing should be to recover your database, right? And yeah, so you need to check the logs and the errors into the logs. D message, general CTL are the some of the or the file system check or the memory test. Those are the system tools which will check for the scan through the your file system and the memory, and it can try to give you the hint of the corruption, and you can use those tools. There is a module called PG surgery, which basically provides the various function to perform the surgery on the damage relation. But as if you will go and try to read the document, it says it's totally unsafe. So if you know how to use that tool, then only you should try to use that, because it directly marks some of the bits to the file system, and that is bit risky. If possible, use the recent physical or the logical backup. which says like backup is a important thing. I mean, if you miss out those important thing while setting the database, then probably you should do first.
Anything to be done on the code side to fix the database corruption?
Code, in a sense, database code.
No, yeah, PG, the Postgres side.
Yeah, I mean, there are few corruption which do happen with the bugs in a PostgreSQL. Yeah. Use pgdump clean. So if you identified like, okay, this particular table has a corruption, you can, first thing you can do is try to take the backup of other tables, and you can use pgdump for that. You can rebuild your index vacuum table, as someone's saying. So yeah, these are some of the things which you can try to recovering from your database corruption. We already talked about some of the prevention tips, but yeah, this, as we are taking the enable checksum on your database. So while doing the EDB, you can do data checksums. No, you have to do it during the initialization. Fsync on, I mean, there are PostgreSQL developer which, if you try to find out the blogs, they will strongly say that never turn this off, because PostgreSQL with fsync on PostgreSQL ensure that data is flushed to the disk before any transaction committed. So this will help the prevention of the corruption. Then there is a full page write, should keep it on. Basically that writes the full content of each modified database page to the wall to the first time is modified after the checkpoint. So you have a whole block into the wall. You can enable full backup and the incremental backup and wall archiving to your system. Regularly monitor your Postgres logs. Keep a standby replica for failover in case of corruption. Please avoid using kill -9 to ensure the system proper shutdown. Run the integrity check regularly, like we talk about, like pgcat check, pgam check, or pgchecksum. We are moving bit faster because of the time constraint, but yeah, if you guys have any question, we can of course hold it there. Okay, third case we wanted to discuss is the auto vacuum and workaround or risk of auto vacuum failing. So what is auto vacuum? Like auto vacuum is a PostgreSQL background process which basically responsible for cleaning the dead tuples and prevent the transaction ID wraparound. So what happens if its auto vacuum fails, right? So it means that PostgreSQL is unable to perform the vacuum operation effectively. That leads to the table bloat, that leads to the performance issue into the system. Right. What are the common reasons and why auto vacuum fails? There can be various reasons, and these are some of the reasons which we have listed, but of course this is not a Bible, so different people kind of get different sort of reasons. But yeah, common reasons are like long running transaction which blocks auto vacuum, high system load that cause the auto vacuum lag, there's a disk IO or memory bottleneck, and insufficient auto vacuum max worker and auto vacuum nap time settings. There are few cases where I have seen where customer has by mistakenly switch off the auto vacuum. That is really dangerous. Many a time you feel like, okay, I'm smart and I know when to turn on, turn off auto vacuum. Please don't do that. Now, what is a transaction wraparound? So PostgreSQL use the 32-bit transaction ID, which means it can handle approximately 2 billion transactions before it actually wrap around. So if table is not vacuum in a time, older XID are frozen, and when the wraparound limit exceeds, in order to prevent the data corruption, PostgreSQL will stop accepting the new transaction. Now, signs of wraparound, you might see the errors like these, like database must be vacuum within this transaction sort of errors. There can be error like uncommitted xmin number from before xid cutoff. These are kind of a sign of like somewhere auto vacuum fails to vacuum the particular table. You can check the auto vacuum failure by this query, which basically tell you that for which relation auto vacuum failed. If your system is getting slowed down and doing the extensive transaction ID lookup, that might be a hint for that auto vacuum fail. So you can look at regularly monitor the PG wait events and try to see if there is a extensive transaction ID lookups. How you can prevent? So yeah, tune your auto vacuum setting. Auto vacuum is complex. I mean, if you look at the PostgreSQL documents, there are around 12 to 15 system GUG parameters for the auto vacuum. One need to understand like their system, and accordingly they need to kind of tune their parameters to make sure that auto vacuum doesn't fail or works for their systems. I have listed few of the parameters. We can go in a detail, but I don't know how many we can do. Okay.
I think move forward.
Okay, yeah, let's. If anyone has any question for particular parameter, we can discuss. But yeah, the third point is important. Keep a watch on a long running. It's spelling mistake. Basically, it's a long running transaction. One need to keep and watch which are the transaction in my system which is long running, and long running transaction can not only give the transaction wraparound problem, but there might hit some other problems. So basically it's very advisable to keep a watch on long running transactions. Yeah, there's this query basically which will help you. It will give the age of the particular database. So if the query gives the frozen XID and XID age is, let's say, above 1.5 billion XIDs, that means your system is at high risk. And if it's above 2 billion, then database will stop generating the new transaction IDs. What it means is like you won't be able to do any operation on your database. You can also check the age of the individual table by querying on PG class. For the database age, you need to query on a PG database table. Okay, what are the resolution and the best practices? Increase the auto vacuum cost limit to run the aggressive vacuuming. What it means is like you can specify the cost, like if it's 10,000, let's say, that means up to this cost I'm okay if the auto vacuum background worker runs the auto vacuum on the table. But if you regularly observing like, okay, this is not enough, it's for my database load, then you need to tune that. Manually vacuum the high risk table. As in the previous slide we have seen these queries, you can look at the output of the queries and probably you can run the manually vacuum on the table. And for the shortened transaction lifetime, tune your auto vacuum settings properly. Kill long running transaction if needed to prevent the auto vacuum blocking. It's risky, but still in some cases we have seen that many a time some transaction is going on and customer doesn't really care about that particular transaction, and they are okay to kind of if you kill it. So we have also tried out those things. In worst case, use the single user mode to recovery PostgreSQL from shutdown. You can log into the single user mode, try to identify the table which basically need the vacuum your tables, and then you can turn your system again. Best practices, you might feel like it's in every slide, but it's really best practice to regularly monitor system catalogs. These system catalogs are made for the user to kind of understand what's going on their system. So yeah, in case of vacuum, you can also monitor the PG stat all table. Set up the alerts for the age of the transaction. one can set up the alerts and see like, okay, if my particular table goes 1.2 or 1 billion, wherever it gets the alerts, and you kind of know it's a time for a vacuum. Schedule the proactive vacuum for the high writes tables. It's the same. Yeah. By transaction age, what do you mean?
Yeah, I think it is transaction is the term, and the table which is holding the oldest transaction, that could be a table age with respect to transaction. If database is doing something, which generally we call a transaction age, but it is whole database with in all tables.
You're talking XID age, right? That's okay. Yeah. We'll move to the fourth case. I'll hand over to Dilip.
You mean to say the tool vacuum DB tool? Yeah, yes, vacuum DB is manual command. Yes, auto vacuum is doing your things, but sometimes if you feel that auto vacuum is not keeping up with its tuned parameter, although in long run you need to tune that better, but you can do vacuum DB to get immediate bloat removal, or removing the wraparound risk wherever you see a log that it is possible that it can wrap around. So you can do vacuum DB to vacuum whole database, all the table in that database. Wherever database age, transaction age in the database, you think it is at high risk. If table are not getting modified, but table have a old transaction, so it will come in auto vacuum also, because auto vacuum look for the freeze also and vacuum also. So there are two things, right? One is a vacuum for removing the bloat, one is for freezing. So there is a if your table have a XID which is of old age of like 2 million transaction, older transaction is there, which is dead. In that case, your auto vacuum will select that for freezing auto vacuum. Freeze means removing the transaction ID and marking it as a frozen transaction ID. So that is there. Auto vacuum will handle the freeze case as well.
And in some case, vacuum DB is also costly because it's do the vacuum on whole table, whole database, right? So if you identify the particular table which is needed for the vacuum, that's always better.
Okay, so let's talk about the last issue of today, although it is not last issue of PostgreSQL, but at least for today. So I am not talking about all logical replication here, but streaming replication. So streaming replication work by continuously sending by wall sender from primary to replica, and replica applies those wall continuously to stay in sync with the primary. That is the working mechanism of a streaming replication. The replication lag we call is a delay between the time when you actually write the data on the primary with respect to when it actually got applied to the standby, and that time duration we call it replication lag. It can impact the performance as well as the system availability. Like in case there is a problem in primary, or the slow connection rate, or any problem happen in primary and you want to fail over, it will affect the system availability because your standby is not yet in sync or far away in the sync if you haven't tracked the replication lag timely. There are options of synchronous replication as well which keep it in track, but we cannot make all the standby as a synchronous replica because there is a cost involved. What causes replication lag? So in simple terms, there could be a multiple reason, but in simple terms, the rate at which we are generating a wall on the primary, standby is not able to keep up with that rate. So one of the common reason we have seen is a network latency between those two nodes, because it depends bandwidth is enough or not, how much volume we are sending, is there any network congestion. All these things can cause this lag. Slow disk can also cause the lag, because when we send a wall to a standby need to flush that wall and then need to be applied. So if it is disk is slow on standby, it is not flushed on timely basis, then it will not be applied also. So lag will continuously be increase. Limited CPU rate or a slow processing power on the replica, that will hit the apply rate, and that is also in ultimately a lag, right? Because you have written the vol into the replica because the disk is fine, it is fast, but you are not able to apply at the pace what primary is generating. And that is eventually true in most of the cases, because primary you can generate a lot of concurrent operations with the multiple backends, but there is only can be a single recovery process which apply on the replica. So, and if that is not powerful enough, or your CPU is occupied by multiple other queries on the standby or in the system, also it will cause into this lag. Yeah, I think then second part is the high concurrency workload on primary. Of course, because of high load on primary, standby won't be able to keep up. Identifying a lag. So I think that is very important that you frequently monitor that PG stat replication and see what is your lag. Even though you are not using that replica for the load balancing purposes, and you are not, you don't have requirement to send, get a consistent result from primary to standby, even though if you are doing a load balancing. But still you need to monitor that thing, because in case of failover or disaster recovery also, if you want to failover to the standby, it should be close to be in sync, right? Even though it is lagging behind, it should not be like a lag of 2 days, then it will really hard, your application will face a downtime. And if you see that lag is increasing sometime over the period of time, you can see your network bandwidth and all other parameter, disk rate, but you can see this parameter also on the standby. You can see, is it in recovery, by any chance is it came out of recovery, or vol replay is paused, or, and then we can monitor what is the last receive LSN, what is the last replay LSN, and last replay timestamp. Based on that, you can predict where is the problem, whether it is receiving end is slow because of network, or your replay is slow because of either slow disk that you are not timely flushing it, or because of slow processor that you are not applying at the proper rate. Okay, so mitigating the application lag, first thing we need to identify there is a lag. So of course, regular monitoring of PG stat replication is very necessary to identify what there is a lag, first thing, and then you need to identify where is the lag. If because of network bandwidth, you can actually increase your network bandwidth, because whatever cause of the problem, that will be the solution. You cannot apply the solution anywhere else. And if it is because of some configuration issues, you can tune your vol buffers on the primary, which can hold more vol in the memory. So recent improvement, I think PG16 there is improvement where you can directly stream vol from primary to standby from the memory itself without flushing the disk. So there this vol buffer parameter can help. Vol writer delay you can improve, that can also help in reducing the lag. And if you think that the network bandwidth is sufficient, but you cannot increase it more, maybe you can considering a vol compression. It will have a CPU cost, but it will increase the transmission rate because your vol size is reduced. And then if it is, you've identified that everything is fast and only replay is slow, then you can try to add extra power to replica, or make get a powerful machine, so that can help in applying the vol faster. Any question in this? Yes.
Can long transactions affect replication lag?
Yes. Suppose you are running a long query on a standby, and from primary you have run a vacuum, which want to get rid of certain data, right? But that query is holding a snapshot, and you cannot get rid of the data. Although there is a conflicting, there is a streaming delay parameter which you can set, which will kill the query. But if many customers I have seen, they set a streaming delay value to 0. 0 means wait infinite for that query to complete. So if long running query is running for very long time, and if you are not killing it,
it means the wall apply will wait for that query to get completed. Once that get completed, suppose in 2 hours, you got a 2 hours lag. So that is the problem. Anything else? Okay, I'll hand over to Rushabh again to discuss some good practices in PostgreSQL.
I think this couple of slides is just a summary of what we discussed in the talk. So there are some good practices, and we are not kind of claiming that these are the only good practices. So again, yeah, monitor your database performance. Keep looking at the PG stat activity, which will give you the understanding of your database. Identify the long running queries that might be causing the performance. Monitor the Postgres logs. Don't ignore any error in the Postgres log. As a user, as a DBA, or we as a developer, the first thing we look at is Postgres logs. So yeah, keep monitoring there. Check your logs. You can look at the PG logs and detect the queries which is kind of causing the deadlock or the blocking in your application. Monitor your slow queries. You can set the log min duration statement. Basically, this will report any query which is taking longer than what you have set the parameter. Identify the unused index. You can look at the PG stat user indexing to see that which are the index which is I have in a system but it's never been used. Try to analyze the situation why it's not used or what, and if it's not needed, you can delete that and or create the missing indexes. Yeah, regular maintenance of your basically it's about the vacuum. Make sure your auto vacuum is vacuuming your table correctly. If not, then monitor it and manually run the vacuum analyze. You can also monitor your auto vacuum as we discussed, like look at the PG stat all tables and see that where auto vacuum was missing for the particular table. This will give you the list of tables where auto vacuum has never run. Re-index table to optimize the query performance if needed. Monitor your database size. Sometimes it happens that the database is growing very fast and you are not kind of identifying that problem. So keep monitoring the size. If it's increasing more than your expected things, then it's a good kind of alarm to look at your logs and see what's wrong in my system. These are the backup and disaster recovery. Like take regular backup. That's really important. Please take a backups. Check your application status. Check your recovery plan. Many a time, all the developers or the user takes the backups and everything, but they don't know what happens if something goes wrong. So you should have your plan, scripts, whatever it's ready to how you are going to recover from your database, because database down is the business down, right? So need to make sure your database is up and running. Resource usage and hardware monitoring. Check out the CPU monitor usage and check your disk space. Monitor active connections. This will basically give you hint if there is something wrong in your system or the database. Upgrade your database. So PostgreSQL release the minor release every quarterly. So we would encourage everyone to do the minor upgrade because it has some bug fixes which has been identified. So it's really important to upgrade your database to minor version. Upgrade your extensions. If you are using some extensions, many a time we are used to upgrade the database, but we kind of miss out on upgrading the extensions in your database. Also upgrade to the major version because it has a lot of features and the bug fixes which cannot go in a minor releases. So it's always better to keep a track with the new releases. So yeah, these are the things we have. There are few references which we have used to kind of preparing these slides. So it's listed here. But yeah, we are open if anyone has any questions.
So why do we need to re-index, database basically? Once the index is created, right? It is created deterministically, right? So why do you need to delete any data?
Reindex is not actually deleting and dropping and creating again, but reindex is reloading the data from the table to the index again, and almost you are reading all the data and creating the index again. Your question is why it is required, right? So, like our software are never bug free, whether it is PostgreSQL, whether it is OS or whether it is hardware, right? Everything have bugs, that's why we all are here. So because of bug, if some of the, suppose assume maybe it is PostgreSQL bug itself, or it is a OS bug, that some of the link, the index is, you are searching the key in index, it is just a B-tree based structure, right? Some of the navigational link is broken, that pointer is not correct, you are not going to the left pointer, you will never find your tuple, right? So that means you will do the index scan, you will never find your tuple. So you need to re-index and rebuild the index, you cannot fix that link manually. Right, in some of the cases in data corruption, and somewhere if you find that a lot of bloat has gone into indexes, that some of the dead tuples are there in index, and because of vacuum, even though vacuum is running, that all the dead tuples are not getting cleaned up, and you think the size of the indexes have increased. So if you re-index, it will freshly build with the only with the data which is actually valid at that time, not with the dead tuples. Everything you can get rid of. So that is kind of a maintenance operation. Response to the bloat.
Confirm the wall record. Master will wait for few minutes. Is there any work? Is there any approach to overcome that problem?
What is the problem? Can you repeat again?
Like in case of synchronous application code, if master didn't get acknowledgement from the he will wait for the he will wait for much time. Right? Is there any workaround to overcome this problem?
I think if you are setting a synchronous application because you want that if standby don't respond, don't move the master. If you move the master, the whole purpose of synchronous application is failed. So there could not be any solution for this problem, because this is the solution of the replication lag, or when you want to use the load balancing, you want to ensure that when you claim the transaction is committed in the primary, it has to go on to the synchronous application, because if you query there, you should get the same result. So if you come up with a solution for this, purpose is failed. So timeout means you want a transaction to be timeout. I'm not sure that it's sync replica apply timeout do we have or not. You mean to say the response should be a transaction failure on the primary itself?
I don't think so.
Yeah, there is no such parameter.
We can continue discuss offline.
Yeah, we are already at end of time.
Thank you everyone.